Welcome to Brain Vision.
The initial energy of the flywheel is used for two purposes. One, to give the car translational kinetic energy 20 times, and then to replace the energy lost to friction from air resistance and from braking. So we can say that the work of friction is going to be equaling the final kinetic energy minus the initial kinetic energy. And so we have the force of friction times the displacement in the x direction times cosine of 180 degrees. We know that this is going to equal -1. This would be equal to 1/2 times the mass of the car times the velocity of the car squared minus the kinetic energy of the flywheel. We can then say that the kinetic energy of the flywheel we know to be the force of friction times the change in displacement in the x direction plus 1/2 times the mass of the car times the velocity of the car squared. This is going to be equaling 450 newtons multiplied by 3.5 times 10 to the 5th meters, and then plus 20 multiplied by 1/2 times the mass of the car, 1100 kilograms, times, this would be 95 kilometers per hour multiplied by 1 meter per second for every, let's get a new line. Again, 95 kilometers per hour multiplied by 1 meter per second for every 3.6 kilometers per hour, quantity squared. And we find that the kinetic energy of the flywheel is equaling 1.65 times 10 to the 8th joules. This would be our answer for part A for the kinetic energy of the flywheel. For part B, we can say that the kinetic energy of the flywheel is equaling the rotational kinetic energy, 1/2 times the moment of inertia times the angular velocity squared. And so the angular velocity would simply be equal to the square root square root of 2 times the kinetic energy divided by the moment of inertia I. And so this would be the square root of 2 times 1.652, we'll round at the very end, times 10 to the 8th joules. And then this would be divided by 1/2 times the mass of 140 kilograms times 0.75 meters, quantity squared. And we find that the angular velocity is 2200 radians per second. This would be our answer for part B. For part C then, to find time, we're going to use the relationship that power is equaling the work over the time. And so here, the time would be equaling the work done by the motor divided by the power. And so this is equaling the work done by the motor, which is equaling the kinetic energy of the flywheel. Again, 1.652 times 10 to the 8th joules, and then this would be divided by 150 horsepower. And then there are 746 watts for every 1 horsepower. And so T is equaling 1.48 times 10 to the 3rd seconds. This would be your answer for part C. That is the end of the solution. Thank you for